This video focuses on moisture and the way wood fibres absorb moisture and the behaviour of wood under different moisture conditions. In a tree, the cells are pipes, and as the tree is growing, they're conducting water up and down through the tree so that they're full of water. In a growing tree, the weight of water is about the same as the weight of the wood fibre in the tree, and the moisture content is 100%. Then, once we start drying the tree out to make actual timber, then the timber is going to have a lower moisture content than the tree itself. The first moisture that comes out of the cells is the moisture that's in the middle of the cell, in the hollow of the cell. So that as that moisture is pulled out, the moisture content drops from near 100% down to about 25%. At around 25%, we call it fibre saturation point. The only moisture left in the wood at that point is the moisture in the cell walls. We can illustrate that using some sponges, because the cell walls themselves are porous like these sponges. As the moisture is in the cells, it pumps the cells up, and I can illustrate that by wetting down one of these two pieces of sponge. You can see that there is a difference in the cross section, so that this one here is fatter because the moisture has pumped it up. The one that has been dried out is much thinner. Can you imagine what happens in a bundle of cells like this? As each wall gets thinner as it dries out, so the thickness of the whole bundle is going to get smaller. And this happens with wood. So that if we take a piece of wood which has got millions of these cells, all of which are getting a little bit thinner as they dry out, the cross-section dimensions of the piece of timber are going to reduce. In the longitudinal direction, we don't see much difference. It's just a reduction in the thickness of the cells, not a reduction in the length of the cells. So as a piece of timber dries out, it gets smaller. If it wets up again, it's going to get thicker. Shrinkage if it's getting smaller, swelling if it gets larger. For this reason, we would want to have the moisture content in the timber when it's produced about the same as the moisture content of the timber in service. And that's around 15%. So when timber is reduced to about 15%, we call it seasoned. And it's in equilibrium with the moisture in the atmosphere, in its service environment, and seasoned timber is not going to shrink much nor swell much in service. However, if the moisture content does change in service, there will be some small changes in cross-sectional dimensions, and designers need to take that into account.